Okay, welcome to this DEB mock exam from 2013. Okay, dealing with conic sections here in question A1. So we've got a 3D graphic showing a helmet from a set of armor used by a local drama group. This consists of two truncated cones. The drawing on the right, okay, shows the elevation of the top truncated cone. The true shape of the cut surface is a parabola because the cut surface projects as an edge view here is parallel to the extreme generator. That's how it's a parabola. Okay, use the focal sphere to find the directrix, okay, and the focal point of the parabola. Right, so what we need to get is the focal sphere that fits inside in the cone. I'll show you a little SolidWorks model towards the end of the lesson. So we're going to need to bisect the angle between the cut surface, okay, and the extreme generator to help us find the center point of our focal sphere. So I'm just going to extend down, okay, my cut surface just a little bit here, and to make it easier for me to draw, I'm going to get my compass, set my compass to any radius. I'm going to put my compass on the vertex of the angle between the extreme generator and the cut surface. I'm going to swing an arc on each branch of the angle, and then I'm going to move my compass and swing a secondary arc from the previous arcs I've drawn. Now I'm going to join, okay, the vertex of that angle through those intersection of the arcs, and then they're intersecting here on the center point. Now I need to draw a line, okay, perpendicular to the edge of the cut surface from the center point. So here I'm going to go here. Then I'm going to get my compass, put my compass here on the center point, and I'm going to draw in the focal sphere there. Now the point contact between the sphere and the extreme generator, if we draw a 90-degree line there, from our center point out to our extreme generator, that's where we're going to get that there. Now find the directrix and the focal point. Right, so this is the focal point where the sphere touches the cut surface, and the directrix, if we draw a horizontal line through the point of contact between the sphere and the cone, we're going to have a plane that contains the directrix. So I'm going to continue this line down here, and this is a point view of the directrix as a point view. Okay, so then I'm going to go then at 90 degrees to the cut surface, and this is my directrix here, and that came from the point view here. Now I'm going to get my set square, or my adjustable set square, and I'm drawing this line that's perpendicular to the cut surface onwards. I'm going to draw a line for the axis of the parabola parallel to the cut surface. Now I'm dealing with part B now. Draw a portion of the curve. So I'm going to draw a line at 45 degrees to the axis, and this is my line of eccentricity. Okay, and if I flip it around and go back at 45 degrees, and then go down parallel to the directrix, I now have my vertex. Now this is the lattice rectum. So I'm going to draw lines at any distance apart to hit the line of eccentricity. just take one from the end up there. Right, and it says draw a portion of the curve. So I presume we'd be all right with this half here. Now I'm going to draw one between, okay, V and F, the focus. So the focus is brought up from the point of contact between the focal sphere and the edge of the cutting surface. Now, okay, so we're going to bring these points down to the lattice rectum. Okay, they're going parallel to the major axis of the parabola. Then we're going to get our compass. We're going to put our compass on the focus, and we'll bring it to our first horizontal line and swing back to the vertical line it came from. So back to there, then on to the next one. So up to the horizontal line, swing back to the vertical line. So you can see that one. And then the third one here. There we go. Right. So we have a point here, the vertex. The next one. The next one here, where the lattice rectum meets the line of eccentricity, is always a point. So there's one there, there's one there, there's one there. Right, and then we're going to freehand sketch this in. So here's the SolidWorks model. So you can see that a horizontal cutting plane that passes through, okay, the point of contact between the focal sphere and the extreme generator, okay, where that intersects the cutting plane, we get the directrix, okay, and it appears as a point view for us in our elevation. And the point of contact between the sphere and the cutting plane is the focal point, okay, as per shown in our drawing here. Now, that was a nice question. Thank you.